seem to be any questions about the demonstrated understanding.
No.
Between the answers I gave you and all that kind of stuff, we figured it out. Know how to apply it tomorrow on that test. Okay. If you realize you have a question soon, let me know. Which I just realized I forgot to put in the proficiency scales for today, but I'll fix it later. Alright. So everything with sampling distributions is on this test. One thing I do want to clarify, and so I want to come over, actually we'll pull it up here. Yeah. So 2008, Martian Man, I'll answer that question in a second. I assume that was Nate. Really quickly, I want to talk about something Serena was asking me about. This is an important concept that I think we need to understand. So Serena, what was your question that you had on B here?
I was asking why would be a sampling distribution when you're choosing one value from each day, then doing the mean of it.
So you only have how many means in part B here?
One.
You only have one mean, right? We good with that idea? One mean? So here's what I want you to understand is we did all of our work on sampling distributions to understand how a sampling distribution works when I get a single sample. Because, and I explained this to Serena, how often do you think we're going to have 150 samples of size 3?
Not very often.
Not very often. That wouldn't make sense. How often are we going to have a true sampling distribution that is every single sample of size n equals 2 or n equals 5? No, there would be no point in that. If we have every data value, we would have the population. We don't need to do statistics. And so the idea is, if I could bring y'all's attention over here, the idea is we know, based on the principles we've explored, that our sampling distribution looks like this, right? And so we get a single data value. Boom. Okay, so what is the likelihood of getting this data value or more extreme? What is the likelihood of getting this data value or more extreme? Is what we're going to do. So the idea is that we have one statistic, one mean, one proportion, and so we're going to make an inference off of that one. That's why what we're going into is called inferential statistics. Now, I do want to quickly look at this because actually, Jake, right here. Hey guys, right here. Okay. Choosing 3 days at random. So, with this plan, would they be more likely, less likely, or equally likely to lose funding? I think I explained this to at least a couple of students. That word likely should make me think of what? Probability, right? As soon as I see that word likely, probability, and I've got a sample here, so I'm not even going to try to just do a pure normal distribution. I'm going to convert it to, what kind of score is it when I put a mean of 0, standard deviation of 1? Z-score. Okay. Alright, so I'm not spending a ton of time since there weren't a lot of questions. If you realize you have one later, go for it. So what is that standardized test statistic? It's off that formula sheet.
Statistic minus parameter over standard error.
Statistic minus parameter divided by standard error. Now I need everybody to get out your formula sheet. Remember I told you, sleep with it, study it at lunch. I don't care what you gotta do, but you gotta start to be comfy with these ideas. Okay?
When we turn the model.
Turn model? I don't want you to not have it for the test, so those who I have, I will return. Just turn it tomorrow during the test. Alright, so, quick point of order. What statistic are we dealing with? Are we dealing with a mean or a proportion?
Fourth one.
For 3B.
Well, it doesn't really matter.
It does matter. It's a mean.
I said what?
I know.
Okay.
But I had someone look at me like I was crazy. I had someone who told me it didn't matter which one it is.
Yes, it does.
Just make an inference about it. You don't have to solve all of it.
My point is something else. It does matter for my question. Look, I need y'all to hear me and I need you to pay attention to this. If you start here, this tells you everything you need to know. Because if my statistic is X bar, then I need to look at the mean of what?
The mean of the sampling.
Distribution.
Yeah, but if that's my statistic, my parameter needs to be the mean of
The population.
The sample.
the sample mean.
What
Yeah.
do
Hey guys. I'm gonna come back to this in a second, but y'all are on the right path, but you're making things harder than it has to be. If my statistic is X bar, I need the mean of X bar. My standard error would be sigma of
Really, sample mean.
of X bar, the sample means, okay? And guys, my point is this. Once you write this X bar there, the formulas are on that formula sheet. What does it say? If I'm looking at, so notice there's sampling distribution for means. What does it say for mu sub X bar? It's just, what? Mu. What does it say for sigma sub X bar? Sigma divided by square root of n. Okay? I need y'all to understand, once you write your statistic out, that tells you the rest of this. If I'm dealing with proportions, what's my statistic? P hat minus the mean of P hat divided by the standard deviation of P hat. And then you go to the formula sheet. Guys, pay attention to what your statistic is. If you know what the statistic is, you can find the rest of that stuff on the formula sheet. That's it. Slow down and pay attention to those details. All right. No questions off of this one?
Mom's light.
Okay. Serena, you didn't like this one? Was this the one you were asking about, Nate? Okay. So, I'm not going to spend a ton of time on this, but I wanted y'all to see a couple of things. Nate, what was your major question that you wrote up on the board?
I was trying to figure out how you get the standard deviation, because it didn't really say a specific end on it.
Yeah, so if it doesn't tell us a sample size, what is the sample size?
0. Random variable. 1. I don't know.
Oh, it's one?
It's only one.
Okay.
Guys?
1.
If it doesn't tell us a sample size, and it actually doesn't even talk about a sample mean, does it? So was this a sampling distribution at all? No. And so I threw this in here because you have to be able to recognize when it's a sampling distribution and when it's not. This was never a sampling distribution question. This is all about, what do we call it when we have random variable y minus random variable x? Combining random variables. So what is the distribution? What's another way we could say what is the distribution? What are they asking us to do? Cuss it. Right? We know it's approximately normal because both populations were approximately normal, I believe, right?
Yeah.
Approximately normal. Approximately normal. Okay. The mean would just be the mean of y minus the mean of x, because that's how we combine those random variables, looking at those means. Brayden, if you want to turn the desk, you can. Just make your life easier. Your choice.
That would actually make it a lot easier.
So y is the 200 minus the 170 is x. So a mean of 30. Now, again, I need to cuss all this in what? Context. Don't forget that context. And then what would I have to do for the standard deviation of the distribution of y minus x?
Root of.
Square root of
Big.
variance.
So you could do just go ahead and start to the square root, but personally, I'm going to take the time to just do my variances. And what do I do with those variances? What do I have to do? Add them. Don't forget, chaos always what? Increases, right? Chaos, variability, spread is always increasing. Remember, it follows the Pythagorean theorem, right? So you can then take the square root if you want. Not if you want, you need to. But the square root of 20 squared, no, 10 squared plus 20 squared. And so do notice, Nate, if you look at that formula sheet literally has variance 1 plus variance 2. It's just divided by n1 and n2, right? Because that higher sample size decreases that spread. We only had one. that spread wasn't decreased. Does that make sense? Okay. Yeah, and then from here, it's just a normal distribution, right? With that mean and that standard deviation. But when will it have to wait? Whenever that one arrives first, right? So you just have to find this. But does that, what's your question? Bull Snake will have to wait at Copperhead for the train from Diamondback if Bull Snake arrives first. So when,
So probability of something given something.
I don't even know if, I wouldn't do it that way. It would just be whenever y minus x is y Diamondback.
Yeah.
No, we want Bull Snake. Which one is that? That's x. So whenever y minus x is greater than 0? So if this difference is ever greater than 0, then that train is having to wait
Okay.
on this one to arrive. And so I would just convert that z-score to 0 minus this mean of 30 divided by that standard deviation. Was that 500? Okay. And then just put that on a normal curve. So find what that z-score is, and then find the area. And yes, you are right, but it's the probability whenever y minus x is greater than 0.
Okay.
So probability that z is greater than, and so find that z-score. Okay. There you go. Any final questions before we finish with sampling distributions? Looking at that GYU, something we weren't able to do.
Do you have the answers posted for the effort? It is. Yeah, okay.
Yeah, I emailed those to you this morning. Okay. What's up, Ray?
Yeah, I don't know what's up, it's like, there's something with the phone, do you know anything about that? Like, it won't let me in to Office 365, it says like my access is denied. Because I did see an email you sent, I looked on the computer in the library when I was
Yeah.
printing out earlier, but then I tried to access it later with
On your
the
phone.
answers, it just, you know anything about that?
It's trying to automatically sign in with your personal account. And since your personal account's not connected to the network, won't let you in. So change what it's automatically logging you in.
Well, no, I'm logged, like, I don't have a personal account, I'm logging through a school account, I have a school account.
Oh, I think that
I know,
happened
but
when I
like-
tried to log in. on
Like,
my
it won't like,
phone
it
from
won't like
college.
emails or anything.
It's trying to put in your
maybe try
personal
this on your
email.
iPad.
My iPad stays at home because the whole metal detector thing, I rushed into school for one time.
Bro, it sucks. I hate
I
it.
know, that's what I'm trying to.
That's why I
my
never bring
iPad,
my
my iPad
iPad.
has a million
I know.
things.
Just get here like 4 minutes earlier and bring your iPad.
Yeah, why is it something gets ready for
Yeah.
That's not happening.
Then leave her.
Did I get in trouble?
Tell your mom, look, I gotta go.
I'm wasting 6 hours every year
Uh-oh.
having because of metal
Jake,
detectors.
yeah, it's excessive.
We were in school for 180 days.
James.
We're at school for
Alright,
180 days.
so,
It'll take 4 minutes.
Lon, what was your question while James being
I'm at
silly?
you.
Huh?
I need that.
Okay.
Do that.
So really quickly, one point of
It's
order that I do want to point out, because this is actually gonna matter a whole lot soon.
On your phone? You've never looked at your personal email.
Jake, no.
He doesn't have my personal email.
Give it back.
That's not what I'm talking about. I'm trying to log you in.
Don't throw us
On the
in there.
I don't have
If
the
you
app.
want
I don't
to leave your personal email, then I can,
Email it to me there, yeah, that's probably the right thing, 'cause I can check personal emails, it's just trying to log in through a school account on, so I don't have.
It's
to-
trying to log into your personal account through the school network on Safari.
What school? Hello?
It handles the things through the TCSS network, right? And since your phone automatically puts in your personal
I don't
stuff.
have a personal stuff, no, Jake, I don't have a personal Office 365 account.
I know.
And so,
Still
Okay.
put in your personal email.
all that aside,
Tech support, bro.
there's a couple of details that we should be asking about, but I can't force you to ask.
So just tell us.
No, I need y'all to think.
I don't know, I haven't done it.
I'm also doing it.
Okay,
I'll do tonight.
Yeah, trust.
I don't. You didn't do it this weekend. We
Because
had
I
more
was
time.
I spent my entire weekend doing
Wait,
stats
undated?
homework.
Oh.
And
Womp
like.
womp,
What?
I had to play the freaking music.
Yeah, and
That
we
was
had to
fun.
do the
That was
Okay.
buns.
Wait, what stats homework?
I had to watch all those videos, I had to do all the homework stuff, I had to do all the CUIs,
No, I just-
I had to do.
Slow down, slow down, slow down, slow
I
down.
think she makes homework for herself.
Well, she actually probably looks at the homework I give, which you don't. I get
I
it.
mean, I.
but-
It's a lot.
Listen,
It's that question.
I told you,
My point is
it is
that
optional.
I was doing it for practice, cause
I
I'm
know,
confident.
okay, but I would have done the assigned, more mandatory things first and then done homework on what you check.
You're not.
I wanted
Alright.
to feel confident.
All that to say, okay, so Schlag finds 85.3% of the people in his sample are satisfied with the way things are going in their personal lives. But remember, the survey, the data showed that the true proportion is 0.78, right? Okay? So what was the probability that we get a p hat greater than or equal to 0.853? What was that probability that we get this if my true proportion is 0.78? What was that proportion or probability?
0.015.
How likely is that how likely are we to get this if this is true?
Not
Not
like
likely at all.
In fact, we might say it is so unlikely.
It's
It's so unlikely to happen
Oh my gosh.
Did you get it
by
wrong?
chance.
Yes, because I talked about it earlier, and then he said, "Oh, you don't normally do it for this." So I didn't think about it when I was
Okay.
doing the test.
Listen, so it is
PMO.
so unlikely to happen by
PMO.
chance if p equals 0.78. What do we think is not true? If this is super unlikely to happen by chance, if this is the true proportion, what do we think must not be true?
The true proportions, like, not.
Yeah. We don't think the true proportion is 0.78. There is, what do we call that? It's so strong of evidence, we call it statistically significant or convincing evidence. It's so unlikely to happen by chance alone if this is true. There is statistically significant evidence. Statistically significant.
Wait, did I get this right? I forgot. I didn't check.
That, what is true?
You need to check.
P is,
more than 70.
so we're gonna actually learn about this. Okay, this is what we're about to go into. There are times when we could just say it is not equal to, and there are times when we would say that it is greater than. It depends on the hypothesis test from the beginning. In this case, is it closer to they're just not equal or that it's greater?
Greater,
Why?
because 0.853 is greater than 0.78.
Right. 100%,
I
right?
don't understand where it's asking for that in the question. Like, I don't get it.
Does this provide convincing evidence? And actually, it does say that more than 78% of his community are satisfied with the way things are going. We calculated this probability in the previous question, didn't we?
Yeah.
Okay? The probability that we get a p hat, and this is what we need to remember. This is a p hat assuming, bless you,
Bless you.
p is equal to 0.78. Assuming that p is actually 0.78, and then we had what sample size in this problem?
Over 30.
No.
I don't know.
Ooh, that means something I gotta talk about.
150.
150 people, okay? A sample size of 150 with that population proportion, this is the probability that we actually get this statistic. That's super unlikely.
What's up with that, please?
This one right here,
What's that?
that's a hat. I screwed up the hat.
Let's go there.
Yeah. Okay,
Oh,
Like
you call me what?
I called you a Tilda.
okay. Last thing is moving away from all that. Guys, I need y'all to focus on this really quickly because this is gonna matter a ton later. Large counts
Probability.
versus
10%.
Central limit theorem.
central limit theorem. overall, listen, overall, you always need the 10% condition because most of the time we are sampling without what? Without replacement. If you are sampling without replacement, you need the 10% condition satisfied. But large counts and central limit theorem are all about what? Normality. This is what determines if a sampling distribution is approximately normal. However, the vast majority of us flipped it. When do we use large counts? What is large counts? What does it literally say?
The
N
probability
times
of
P is,
success is
Greater
greater
or
than
equal to
10.
And
One minus.
Yeah, looking for
yeah.
so if we are dealing with proportions, we're using the large counts.
CLT's the lead.
The central limit theorem, so this is all about proportions. The CLT, the central limit theorem, is all about means. And what does the central limit theorem say?
Something
If
If it's the sample size is sufficiently large.
Sufficiently large. Does the central limit theorem ever say n is greater than or equal to 30?
No, but
No,
for
but
this
you have to
class, we do.
30.
And for the AP
Yeah,
exam.
AP exam, yeah, this class, yeah.
Now, so if n is sufficiently,
Peter, can you write one more time? I'm gonna scream away.
then what is approximately normal?
And the sampling is not on the sample mean.
So I need y'all to pay attention to what Peter said. It's not just any old distribution, Michael.
Okay, whatever.
You having fun on your phone there?
Yes.
Get off of it. All right. Is it the distribution of the sample? No. Is it the distribution of the population? No. It is the sampling distribution. I'm so sorry, Michael. I'll try to be less boring in the future, but also I need us to learn crap. So, key ideas. I need you to know, okay? Large counts condition only goes for what? Proportions.
Proportion.
Central limit theorem only goes for
Mean.
means. Si, senor.
Okay,
What's the thing with the expected value again?
okay,
Oh no.
so
What's the name of
outside
that?
of stats, what is usually the essential limit? Like, what is the limit that they usually, that's sufficiently large to what?
So the reason why it says sufficiently large is it depends on how skewed the data is. The more skewed the data
So
is,
it's like.
or the more non-normal it is, the larger the sample size. So a sample size of 30 is pretty sufficient for almost any distribution you could run into. But like if it's like this, we can agree that's slightly skewed, right?
Yeah,
Yeah, an N of 2 would probably normalize that.
okay.
An N of 4 would normalize that. So it's about how normal the distribution already is.
How do you determine
Is
this?
it because?
You don't.
You just kind of say what you want to say.
Wait, is it because?
That's why you say like it's sufficiently large and
Not
we
exists.
go off this. Now, sometimes we have an inkling of how normal the population is based on a sample, and I'll explain that later. That actually comes up in next unit, not the one we're about to start, but the next unit when we look at means.
Wait, so if CLT is true, does that mean like that's because like once n is increasing, variability decreases?
It's not just that. So it's not just about the variability decreasing. It is quite literally that as that sample size increases, yes, spread decreases, but more importantly, the distribution approaches normality. So remember, it's not about, that's not about spread. That is just about approaching normality. But again, yes, what n is sufficiently large for AP statistics?
30.
30. There's something I was just thinking about. Maybe it'll come back to me later.
That's a D.
Oh, that's the question I was going to ask. So, do you always have to satisfy the central limit theorem for means?
No.
Why not?
If the distribution is already normal,
Distribution is already.
Yeah, they
Which distribution?
the mean.
the one you're sampling
Population
from.
distribution. So, here's what I need y'all to be careful about. We have gotten far enough along in AP stats, don't ever just say the distribution. You need to call it a sample distribution, a sampling distribution, or a population distribution, right? So if the population distribution is already approximately normal, then the sampling distribution will always be approximately normal, okay? Alright. Let's see, from here, Ms. Kowalski, I'm gonna start passing out the stuffs. Do you wanna start talking with them about this?
Yeah, guys, I get to teach you today. Are you so excited? You can leave. You can leave.
Wait, we can leave?
Y'all got 5 seconds to get back on task.
Shoot.
Okay. On 4, 3, 2, 1.
Do I have to tell me
Do
try?
we already have this?
Run like the wind.
No, I'm about to pass it out.
Run like the wind.
You wanna go ahead and start explaining it to them based on,
Jeez.
Ooh.
yeah.
You didn't really explain to me how we're doing.
Oh. I got it.
didn't really explain to
Okay, so,
me. Like,
we got a massive thing of M&Ms here.
like Peter?
Peter, what proportion of these do you think are red? If you want to pass these out there while I go through this.
Who counted this?
I'm not counting all that.
I changed it because it's already red on here.
Oh.
Yeah, you're good.
Okay.
How many? Say again.
Passing out all
I don't know.
No guesses?
No?
Pretty good guess, I don't know.
What do you think?
Like, proportional?
Yeah, what proportion of these do you think are red?
8%.
1.18.
666.
No, 4%.
0.18%?
1 over
Let's do it.
So 20%? 18%? Okay, that makes way more. I said percent. I said
Oh my god,
proportion.
freaking
4%.
packets.
Okay, 4%, 20%, 18%. Yeah, but in the most respectful ways, y'all are not asking a really important question. Yeah, the blue and yellow.
Are there red ones?
Wait, wait,
There are red ones.
Are there red ones?
Back up, back up.
What's this?
Does it matter how many are in here for a percent?
No.
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 Hey, but guys, hold a second. Y'all are in a stats class.
We're gonna average.
Does
We're
it
gonna
matter?
average our estimates.
We're in a stats class. What are we missing?
Oh my god.
Stats.
There's something you need before you can say stats.
Class.
Starts with a D.
Distribution. Wait, why?
Data.
Say it again.
Data.
Guys, why are y'all trying to make guesses in this classroom? We don't just look at You should have said, Mr. Kenny, I need data.
We're collecting data by asking them.
I have data.
Listen, I said, I know I did, okay? I had to wake Michael up here, okay?
DMO.
Listen, okay?
You legit asked us.
I know, and I knew what I was doing, so Michael's awake. All right, so look, hey, we don't want to make guesses. We want to make informed decisions, so what do we need to collect? We need to collect some
We're
data.
collecting data.
Say again,
I
sorry?
did
collecting
just run
data.
out of here.
Okay.
Say again.
We're collecting data.
We're about to, we haven't
We
yet.
are right now. Because, like, if you average.
James, just stop. All right.
Average everything, it's
so-
a pretty good guess.
Oh, that's for you.
Let me ask you this question. Okay, we're looking at these M&Ms.
I think.
And by the way, right here, okay? So I decided to go with something other than beads because one, I can eat M&Ms and they're fun, and two, beads are lame. But the goal is to estimate the mystery proportion of the M&Ms that are red. Instead of simply giving a single value estimate, because I want to pause and I want you to think about this. How likely is it that you get one statistic, one sample, that knocks it out of the park and perfectly gets the true proportion?
Very extremely tiny low.
Extremely tiny and unlikely, right? However, what if,
Thank you.
so I'm making this up, this is not realistic, please hear me clearly. So if I get a p-hat of, I don't know, 25, okay? How likely is that to be right?
No.
Not very likely. But let's say I then take that p-hat and I add a little bit to it and I subtract a little bit from it, and so I get an interval of 0.45 to 0.5. Now, I have a set of values, anything from 0.45 to 0.55, that I'm like, that might be my true proportion. Is that more likely to be correct?
Yes. Just like a little bit more.
Just a little bit more, right? Well, what if we could use everything we just learned about sampling distributions
Oh my god.
to make an informed decision about what interval it should be?
So this is all about how like you don't usually actually have like the population.
language interpreter.
Exactly!
Like those fake ones?
In statistics, hear this guys, I need y'all to hear what Greg just said. In statistics, how often do you have the population?
Not top.
Not at all, right? This is why I brought up what Serena was asking earlier. We don't usually have the population. We don't usually have multiple samples. We have one sample, okay? One sample. And so with that one sample, we use our understanding of sampling distributions to make an estimate of prediction. Alright, so Ms. Kowalski, can you give everybody needs to come grab a paper towel. Got one for everybody, okay? I need you to each grab, how many M&Ms do you think we should grab to give us a good estimate?
30 handfuls.
How many are in there?
33%.
Great question, no idea.
The whole thing.
The whole thing.
No.
I mean, we get a population that might know. 30 makes sense to me.
16666.
Um,
50.
Yeah,
let's-
that's 50.
50.
There's a
50
lot.
would give us more data, yeah.
50.
But hold on a second, guys, hear this, okay? 50 would give us more data, but what could be the problem if we just start to increase our sample size?
It takes a lot of effort.
Well, we didn't really run the risk of not being independent.
Oh, so we might violate what condition? The 10% condition. I'm glad you're picking up on that, right? We can't have too high of a sample size because then our samples might not be our selections may not be independent of each other, which would violate the independence condition or the 10% condition. Braden, eyes and ears here. So, to be safe, and based on what I've done in the past, I need every person to get 20 M&Ms.
I'm not counting all of
Shouldn't we do?
Wait, okay, Peter, what's your guess?
Oh my
What's your guess
god.
for proportion?
I don't know, I didn't know.
Guess, real quick.
I didn't know.
Guess.
Well, this is
I'm
whatever
trying
they
something,
get.
I'm
That's
Okay.
just whatever they get.
Can we wager this?
Alright, fine. I will pick out your 20 M&Ms.
No.
I tried to give them to you,
Brandon,
but 5,
Brandon, what's your
7,
guess for
8,
proportion?
9,
4%.
10, 12, 13,
Nine.
14, 15, 16, 17, 18, 19, and 20.
Wait,
Someone
you
grab,
Michael.
Can I take
someone
my-
come grab them.
Can we do our own?
Mike, what's your guess
Yes,
for
so
proportion?
stop complaining, get your tails up here.
That was the goal, for you to
Okay,
get.
actually, can you hand me
Just
this?
around like what?
Here's what we'll do.
Oh my goodness.
Alright, here you go.
One over 5.
Get your 20 out of here.
Close to it, Elliot.
Share this a little bit, get your 20 out of here. Once you get your 20, come pour them back.
So how do you take?
99%?
Oh my gosh, I lost
Rob, because those is yours.
So that's.
Where is that? Yeah,
I'm
I feel
gonna
like
say
do I have it?
90.
I'd say you were using it.
It's so addicting.
Okay.
We'll find it.
Yeah, talk about this
My
first
mom-
really quickly.
Put M&Ms in my grandma's mouth.
Alright, so each of you should have filled out, number 1 and 2 with your own, proportions, so should I just use anybody's or just?
I mean, yes, but, hey guys, I need y'all to read. It defines what a point estimate is right there in bold. This is your point estimate,
Yeah.
right?
You got
Did you not do your own
point.
sample?
Okay,
No.
so
Point.
P hat equals whatever yours is. Yeah, continue on.
Identify population, parameters, sample, and statistic. Guys, what's the population?
The
The
jar.
entire
Jar.
jar.
M&Ms in that jar.
All
M&Ms in the jar.
in jar.
Do you drop everything?
Be careful and please note,
Drop it like
it's hard to make an inference outside of this jar. Why?
Because it's, you know.
Maybe it came from a different factory or something.
You know, there are 2 different factories out there that produce M&Ms and they have different percentages.
What if it was like
Actually-
Valentine's?
actually,
Day?
yes.
They have the pink M&Ms.
Yes, ChatGPT, baby.
Okay.
Nerd.
Red 40 shorties or.
Alright, sample. What was our sample?
It's in band.
The
20
M&Ms.
20 M&Ms selected. Parameter.
True
True proportion of red
in the entire
M&Ms in
jar.
the entire jar.
Alright, P equals true.
Ms. Wilson, can you do something for me real quickly? Put a colon after that P, please. You equal numbers. Do you know what comes after a colon?
A definition.
A definition. So, on the AP exam, I would highly recommend put a P and then a colon because you're defining what P is. The equal sign is reserved for equating to numerical values.
You got it. You
I
got
think
it.
this is
Sorry guys, it
You
says
got
equal
it.
on the key.
I know, I
Studying.
it's written by math people, not people that understand the clear connection between math and English. That's a thing that bugs me.
These kids judge me when I get one little thing.
It's not you, that's them.
So
When
what
did
is
we
our
judge?
statistic?
When did we judge?
The amount red that we got in our thing.
P hat
Oh.
Colon.
Equals something.
Oh.
equals whatever your
Close
number
enough.
is. What equals your what? What is your p hat equal to?
Our point
Sample
estimator.
Your point estimate.
Okay.
Beautiful.
You couldn't have happened to accidentally take it downstairs, do you think?
No, I didn't have it in my hand.
Have one, the clicker.
Yeah.
She obviously robbed you.
She lost you in
I stand behind that paper right there.
Oh, I see it too.
That one was
Guys,
me.
How'd she
Can
do
y'all
that?
That
get
one
like,
wasn't
I
me.
need a prize or something for that, guys, please.
Of course, you
No.
should more food.
Continue, please.
All right. So now we will choose value, add and subtract, blah 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 blah.
And this is what I just want to point out, guys. I need you to read what you add and subtract from the point estimate. You don't need to make up your own interval. You start at the point estimate, and then you what? Add and subtract. When you add, that's going to give you the maximum, subtract the minimum. Sorry, that was just frustrating because it was like trying to
they
make up
didn't
our
read-
own intervals. They didn't.
They didn't read the
They didn't
directions?
read the directions.
Oh, okay.
We didn't
Well, if we don't
Why are
trust
you
our
looking at
samples.
Look at you. Look at you.
Then you combine that data if you want.
So you start at your point estimate, plus or minus margin of error.
We gotta announce
Can I just
the
do-
Yeah.
thing.
MOE is, or ME is what we usually do for margin of error.
Bro, stop backseating.
All right. Use your point estimate and chosen margin of error to create an interval that should contain the true proportion of red M&Ms. Give me your interval.
Lana,
0.17 to 0.23. Serena.
0.05 to.
What?
Oh.
That's
hours.
Wait.
0.05 to 0.15.
Oh, that's a different one. Oh,
You just have to wait.
Hold on. Okay.
wait, what?
Jaden, your groups.
We had two, you had four.
Point 12 to point 31
We had double hours.
I thought just point
dang.
12
to 0.31.
to point 3.
point
Point
three.
three.
What did he?
So what did you get?
Did Peter?
Point 15 and point 25.
0.15 to 0.25.
Yeah.
Brayden, whose did you match with?
Well, I had the same other sir, so.
You two have the same estimate? All right.
So,
Do we reveal?
I think it's time to reveal.
Yes.
Now,
Okay.
I will say this.
We're on this.
2 people captured the true proportion.
Two
And,
people.
wait,
Two groups.
wait, so it has to be us then, right? Wait,
No.
I don't
No,
know.
because captured,
It's probably
that
around
means
point
it's
2,
within.
something.
I don't
No,
know.
Oh, no,
like
no.
what Sprig just said, I need y'all to hold on to it. Captured means it needs to be within that interval,
What
right?
is 2-4?
There's overlap. Ms. Kowalski?
Do we
Oh,
like
that's
cross
really
them off
not-
and
what
each
is-
match?
Yeah, sure. Think about it.
We gained
No!
Oh!
wait, I'm
Stab.
put on,
I thought
Oh!
But which group wins?
please let me us.
I mean, ours is like closer to the actual value.
It's not about how close it is.
it's about how small you. We have a small interval.
Do we? No,
Yeah.
No,
well-
you definitely
No, you
do
do
not.
Definitely
Wait
not.
a minute. I'm
Point
just
one versus point 1.8.
Wait a minute.
Ours is 0.05.
No, your interval
Oh,
is
one.
point 1.
Guys, I thought point 9.
Yeah, smaller margin of error.
Wait.
Or
So you
0.5.
won.
You did.
You did.
You did.
Food.
Here's
Serena shouldn't win anything.
Yeah, Serena should not win anything.
To me.
I
think he like doesn't get anything.
I mean, I could do some food. I was thinking some
If I was
bonus
Timothy, I'll
points.
for grade.
Bonus, please.
I like that better.
Yeah.
I like that better.
Okay. Peter unfortunately doesn't get it because
Aw.
he did his own.
There.
He's like, I don't need
I don't
it.
need
What did
that
you do?
one.
Different point.
Alright.
All right, now we're gonna talk.
There,
My
I had a
lowest
different point
was-
estimate.
I mean, we still didn't win.
Anyway, say, did anybody look at their proficiency skills, like what we're working with?
No, I swear.
Yeah.
Never look at that.
Is it actually?
Serena, it's
Wow.
not chi-square. We're,
It'll be
we're a couple
chi-square
units
one
from
day.
there.
Hey, what is, okay.
Oh.
Point estimate.
What is the title of it?
AP statistics,
Confidence
you get
intervals
5
and
to 8.
proportions. Confidence intervals, okay?
Intervals.
So what did we just make?
Non-statistics.
Some people.
What did we just make?
A confidence interval.
Again,
Made an interval.
a confidence interval.
And now we're asking how confident we are in that interval.
I went from
Well, I mean,
37.5
not
to 100.
anymore.
Alright, this was just to get you into the groove of context in your interval in context. What did I say?
Something about context.
Putting it in context,
Yep.
right? Because that is the most important thing in AP Stats. Putting it in context, kind of. Here, one group claims the true proportion of.
Don't skip number 5, we gotta talk about that one.
Okay. What do you want? Somebody give me their confidence.
But now 100.
90.
2%? Okay.
Let's go with what Sprig said.
90.
90% sounds
I
way
like that.
better.
We are
Mine was
90%
I missed a shot.
No way.
confident that the interval from, what was your
Okay,
interval?
With how big it was.
0.12 to 0.3 captures the true proportion of red M&Ms in the container.
I wanted Ms. Kowalski to do this because I need you to hear me right here and right now.
Yes.
That is how you interpret a confidence interval every time. We're gonna find out more about that percent and how to determine what's called a confidence level. But if I give you a confidence interval, you need to say, we are this percent confident that the interval from here to here captures the true proportion of context.
Is there,
That's how you
But how
interpret
do
it.
is
you
there a
find the
specific
percent
way you're
confidence?
supposed to calculate your confidence, or is it just?
Yeah.
Yes.
We're gonna learn
No,
about
no,
that.
no, no, back up.
I feel 50%
There are,
confident.
there's a specific way that we'll go into next lesson and the lesson after to calculate our margin of error based on the confidence level.
Opposite of confidence, so margin of error plus confidence, like that.
Well, we use our confidence level
Okay.
to help us calculate our margin of error.
Okay.
And so we
Yeah.
decide ahead of time, this is the confidence level.
No, you will never be 100%
Ooh,
confident.
that's a great point. Do you know why we'll never be 100% confident?
Sampling variability.
Senses.
Sampling variability, senses, Lana, what are you saying?
I don't know.
What do we not know?
The
True proportion. We don't need a confidence interval if we knew what the true
Yeah.
proportion was.
99.999.
999.
Usually we don't go beyond 99%.
It normally is like,
Well,
it's like 95, 90.
And I will say this, we'll get into this tomorrow, but what do you think the trade-off is between being more confident and less confident?
The
You have to
size
push
of
The size of your
interval.
interval. When are you gonna be more confident?
When it's bigger.
When the interval is bigger. But like if that interval is bigger, then that doesn't give you quite as much, you're not, there's just more variability, I should say. Okay, sorry, we need to get going though.
Okay, so what if like your answers are wrong, but you still did it right? Does that make sense what I'm trying to say?
100%.
What would that do on the AP test? Do you have a partial?
Well, so there's a process that we're actually gonna go into, it's called a 4C method of inference procedures. And you can make a calculation mistake, but still get like a 3 out of 4 because all you do is make a small calculation mistake. Or if you explain everything the right way, you can still get a 4 out of 4 if they can see that it's literally just a small calculation mistake that you made.
Huh.
So, it's understanding the process.
Alright, one group claims true proportion of
Oh
red.
yeah, sorry, I didn't tell you this earlier, I changed those numbers to make way more sense within the,
Oh, real?
Oh, they're not changed on the red.
no, they're not changed on that paper, I already had those printed
Well,
out
the
on
answer's
Friday.
still
I wonder why it was so high.
Does this interval right here support or deny this claim?
Yes.
Why?
No, it does
Uh,
not.
Yes, it does. It's 0.2. It's inside 0.3.
It's within your interval.
Oh, inside.
Yeah,
Oh,
it's
that
inside
is-
of theirs. So yes, it does because that value is within the interval provided.
So,
I mean, probably one
I will say
of them,
this,
like
we usually say captured when we talk about,
capture. Okay.
so 0.2 is captured by the interval 0.12 to 0.3, or you can write an interval notation. Now, we'll point out Serena's value was 0.05 to 0.15, so no, because that is
Highest plausible values outside.
outside.
Another group got 0.145, 195 as their interval. What is their point estimate and what is their margin of error? Michael, how'd you find your
I
point
added those two
estimate?
and then divided by 2.
Alright,
Actually, I do.
Can someone say that another way?
find
The
their
average
mean.
of the
Yeah, the mean.
Right, just finding the mean. I just want us to recognize that.
Somebody have a calculator, I'm gonna put this
0.17.
0.17.
0.17, beautiful.
Because you're just finding the middle, so 0.17.
Alright, Michael, how did you find your margin of error earlier?
I just did each point and then minus 0.1. Oh wait,
Well,
I don't know, like, well, I didn't use that.
No, you didn't, but the way you did it, how did you do it?
I just counted.
Okay. Or
Hello.
what he's saying is he took one value, subtracted this.
Yeah, that.
So margin of error was 0.195 minus 0.17.
Can you write that out?
Point two.
Yeah, sorry.
Point two five.
0.95 minus 0.17, what is it?
Point,
0.25.
0.25, yeah.
And you can double check yourself also. 0.17 minus 0.145.
Negative.
Well, I put the 0.17 first.
Zero point two five,
Yeah, 0.25.
0.025, whatever.
Okay, alright. Okay, notes time.
Did we ever tell them that we figured out what LT stood for? We're gonna start adding it back in.
Left tackle.
Huh? Learning target.
Left tackle.
LT, learning target, the target of our learning. So, you've seen me write LT up there before, LT number 1, LT number 2.
Like right now.
Michael apparently has not.
So learning target,
No.
number 1. This is a D.
See how many points you put proficiency skills out of?
What?
Never mind.
You put the grade?
Yeah. It was out of 1,200 points.
Go.
Estimate plus or minus your margin of error. That's how you create your confidence interval. How do you find your point estimate? If you're given, like if you're given
The range.
interval,
The average.
okay,
So the mean.
The middle of the interval.
which is the,
Mean.
what was the other word you used?
Average.
The average, okay. So, point estimate,
You should write.
I will point this out, do you think that only works for proportions?
This out. Now.
Will it also work for means?
Oh.
So guys, we're gonna do confidence intervals with proportions and means. This applies for both.
how do you want me to write? Just A
I would
plus
just-
B divided by 2,
You talking about for the
B
margin of
minus-
error?
yeah.
I would just say it's the distance or difference from point estimate to an endpoint. There is an actual formula, I just don't think it's necessary to learn another formula. It's B minus A divided by 2.
I hate my government.
It's just a distance.
And to endpoint, alright.
German.
Oh,
Lord.
You got this.
I want to stop. Please.
interpreting your confidence interval is your second learning target. Yay!
So much fun. It's not gonna be on the test tomorrow, right?
No.
Dude.
Tomorrow is only sampling distribution. This is our
Honestly,
next
just
Just making sure.
because it's so easy.
Sure.
It's gonna be
It's because it's fresh on my mind, so I understand.
It's definitely gonna get hard.
It really doesn't.
Like AP stats.
Says the one who's been teaching it for like
I
ever.
feel like we got to the. no,
Let's just pray for everybody else's downfall.
Right.
Wow.
Are we writing this?
Yes,
Or am
we
I
are,
wasting my
actually.
time?
No,
No, you're not wasting your time.
Well, I'm not.
Okay.
It's called Unite and.
Did it work?
Well, what am I supposed to? Okay, I'm sorry. We are blank percent confident that the interval from A to B
Did it work?
captures
Sometimes. Low key.
the true
Do people just start?
context.
What are you talking about?
Like, you don't write captures the true context, you write the context.
Okay. Which test were you
If
guys?
I'm not working with partners,
What?
would I just use I?
So we actually still say we. I don't know why.
Because
I'll look
there are
again,
many voices
but
inside your
I've
head.
always seen it as
It's
we.
always a we.
One quick note.
Eid in the.
Is-
Ego.
This is just a personal thing, you do what you want. Instead of saying from the interval from blank to blank, I would just usually say from that the interval, and I would just report it as an interval notation, right? So instead of from A to B, I just write the interval and then this. Your choice. Either way works. That's just a personal thing.
Wait, would it be bracket then if it was interval?
don't ever use
Yeah,
the
'cause that would be
brackets
a
in
point.
statistics.
Okay, so we can just use for.
Is he part of like a mighty council? That's why it says we.
I mean, in statistics, it is based on the AP exam and how every teacher just does it.
But
So
we
yes,
can't,
So he is part of the mighty council.
Yes.
we can't use a bracket, right?
So I would
I'm
not
saying
use
you
a
should
bracket.
Wait,
I would use a parenthesis.
She pointed a laser beam at me, like.
Oh, you'll survive.
Blind him.
Alright,
And block.
Make him a
Yeah, I think
let's do it,
Yeah,
like together or?
no, then do it.
Alright guys, time to check your understanding.
We got 5 minutes, let's
No, no,
go.
God.
Make it sad.
No, Nicole.
Says
Y'all.
253.
Yeah, you got 5 minutes to get it done.
To do this.
Stop distracting me.
Is everybody done writing these notes down?
Yes.
Yeah, I'm just-
How do you interpret it?
Interpret it.
It's on
It
there.
means testing on.
Yeah.
It's actually learning target number 2.
Oh my gosh, why?
And it's on the front side.
Oh.
But it's also learning.
95.
It is learning target number 2, I like that.
See, I listen.
Thanks.
So like, even if you're interpreting someone else's data, you still say we are.
Yep.
Oh, because I'm just.
Yes, don't make it harder than it has to be.
I'm taking.
Write that statement down.
Can I still say from A to B?
Yes, you can. That's, my point was just that you can do the interval notation or from A to B.
You erase the interval notation.
Michael, have you interpreted that confidence interval yet, though?
Okay.
Like, they already gave you the interval.
Wait, capsule should. Oh, are we supposed to write the context where it says context?
Yes.
Okay.
Yes. You are supposed to write the context where it says context. I know.
Isn't that what you just talking about?
Yes,
Listen.
except dog. Yeah, what's the
I
context?
spaced out, but I didn't write everything, okay?
You gotta put the context of the problem.
Are they all just running context right now?
I'm not
Some of them
high,
That
I
didn't
just.
work out.
I knew what you meant.
Okay.
Alright guys, 3 minutes.
Okay, let me on.
If I can just like.
Student teachers have.
Oh, like-
I'm just gonna write this down and then let them continue to work.
I can do that.
Can I be on what you're on, please?
I'm just not
That
that
was fine.
Why are you doing this?
I'm not even working.
Why are you?
I'm a hostile.
Huh? I'm gonna crash out.
Jayden, did you see Aaron's text?
Oh,
You don't like ads.
Yeah.
I don't wanna talk to him, you go talk to him.
What she said.
Cause they don't
He
use
says,
just put that.
That's a
You
symbol
want to
for
just
the,
write
I don't know, something about like reading an email, which is.
is it still p-hat for the, point estimator?
Yes,
Okay.
that is what's estimating P.
Is it true?
So, we are 95% confident that the interval from this to this is true what?
It's also up here, right?
Oh yeah, he's writing.
A, you can check A on the board.
Point.
You're making this way harder than it has to be. It is this. We are blank percent. Oh my gosh, how do you read that?
I just do.
That is not what it says. That is not what Ms. Polsky wrote. It is this statement. We are blank percent confident that the interval from here to here captures the true proportion of whatever the context is. That's it, every time.
Oh
You
my
gotta write
god,
that
that's
down
a
right
track
away.
thing.
So.
That's why I'm trained.
Yeah, did it already give it to me?
Did it? What do you mean?
Oh my god.
It gave you the confidence interval, so you use it to have your plan estimate and margin of error. So. So.
Which learning target does C refer to?
So then your margin of error, how do you find that?
It doesn't,
Okay.
but it's thinking through what you know about a confidence interval.
Yeah, so the middle, yeah.
Okay.
So they give you a point estimate for, well, that's not your user. It's the, so the point estimate is in the middle of it, right? So you need to find the distance from the middle. So that was your right point estimate. So you did 0.548 minus that. To get your margin
Like this room.
So that's right.
No. Because, so,
What is it? She can get my number.
0.35 to 0.548.
Huh?
Right here in the middle is what you found of 0.45. So you need to find the distance from 0.45 to 0.548.
That's all you put.
And from 0.5 to
It's not a rotation.
0.352. Does that make sense? Okay.
Okay. So let's talk about this a little bit. One thing I realized that we forgot to actually talk about. Oh, there's something I need to finish on adding on to that. Here we go. That's what I was going to say. Something to add under learning target number 2. All values
Wow.
between A and B are plausible. What does that mean?
Like they're included.
Be careful, it's not possible.
They're, I thought you said, they could,
They're like, they satisfy
they're inside the,
They have equal chance.
they're like,
Oh, can you start the camera?
yes.
Thank you. If they are plausible values, they are values that are likely. What are the possible true proportion of adults who pay for subscriptions?
0 to 1.
Anyone?
You say?
35%
Zero to one.
to 54%.
It's 0 to what?
0 to 1.
Isn't 0 to 1 possible?
Yeah.
So we don't want what is possible, we want what is plausible, what is likely, right? So I didn't get a chance to finish it because we needed to go over this, but values above 0.5 are captured by the interval, so it is plausible the majority of adults pay for subscriptions they do not use, but also values, do we have values below?
Yeah.
Yes.
So, but there are values below, so is it plausible that the true proportion is below?
Yes.
So in conclusion, what do we know?
We don't.
We don't,
We do nothing.
right?
Wait, would you put like 0.5 to 0.548? Because it's not like everything above.
So it's just in general, but values above, you can say that, but values above 0.5 are captured by the interval, so it is plausible the majority of adults pay for it, etc. But also, there are plausible values below 0.5. So again, so 1, 2, and then, so we don't know.
Wait, just trying to ask a question. So you said all values between A and B are plausible, or like, which means they're equal, like, they're likely, but are they like equally likely? Like, is the
We don't
value-
know. We just have this interval of plausible values.
So they're all equally likely.
Yeah, essentially. What kind of interval would we need to have convincing evidence that the majority of adults continue to pay for monthly subscriptions? They do.
An interval that's completely above 0.5.
You would need an interval that's completely above 0.5, right? 0.55 to 0.65, man, I wholeheartedly believe the majority are paying for stuff they don't use. Does that make sense?
Yeah, I feel like this is underestimating by the 0.352 and the
I
2.5.
haven't collected this data, it's just how this problem would work. Can you go to the next slide? Yes, please make sure you have plausible versus possible. Unless your name is Braden, I need you to get an iPad out.
No, I don't have an iPad.
Oh, mine
Is
might
there, is there one person
I've
per
got you.
group? Is there one person per group?
be, mine might be there.
Yeah, actually,
But what are we gonna use iPads for?
For the next lesson,
What would this? Do I need a strong internet
Can I
connection?
use my phone?
you could use your cell phone actually.
Okay, what?
I need you to go to, it doesn't work as well, but I need you to go to tinyurl.com/applet, and that is CI, not CL. CI.
Hey Jaden,
What's that, CL?
I may not be able to get to that thing tonight.
That was funny.
I can.
I'll give you that, Peter.
Bye.
I almost responded even.
Oh, it's not
What'd you
tonight.
say?
I studied tonight anyways, I was wrong.
What'd you say?
Huh?
I studied tonight anyways, I was
Oh
wrong.
my gosh, I can't.
Oh, really? I've been asked to take someone to dinner.
Actually?
Yes.
Who-
Brayden.
So,
You have a SIM card?
Is the Michigan girl, whatever?
Michigan.
Wait,
Who's
wait,
from Michigan?
was it like Atlanta, or was it Mississippi?
The person from
Minnesota?
Atlanta? That's no.
You know, I totally tried with CL.
tinyurl.com.
Guess what?
Okay.
Oh, it did say block domain if you typed it in.
Oh,
Alright,
It was CI.
no,
I mean,
CL.
seriously.
Or no, it is CI, golly.
That's not.
I thought there's a safe didn't work with how you were.
That's not.
I wasn't sure.
It's weird, you're weird.
What are you talking about?
It looks like DNA.
Confidence interval.
I like that laugh.
This is concerning. It's concerning. And you know it.
You dropped something.
Like, it actually makes me uncomfortable. I'm okay with
What are we doing? Yeah. What are you doing?
We're pulling out the applet.
I'm saying what were you doing?
Oh, her exit page.
Oh, do I ask you something?
Oh, yeah, you
I have
Did I just
a
ask you?
extreme
Did you say yes?
anger against.
Hold on. You doxed him.
No.
You doxed him.
I can dox her.
Oh, group is too big.
I give up.
When you
Actually,
click the
Or
slider.
not her, but.
He is dumb.
Yes.
Okay, this is it. So, guys, just search confidence intervals for proportions, right here. Search for that. It's BFW Publications, it's actually who makes our textbook.
Wow.
And then he got confused.
I thought
How much is textbook?
Confidence intervals for proportions.
It's like, I get this one. It's so dark, but it's-
Hey, Braden, have you pulled this up on your phone?
It is just now loaded, actually.
The Wi-Fi, wow, the reception
Click
is
here.
not sometimes it's amazing and sometimes it's.
Right. Serena, I know it.
It's called
Don't
Okay.
It's because it's called trauma.
Serena,
Yeah, right.
don't become.
Alright, guys, we should see this
I see.
with an F. Confidence. Oh, that is it.
I see something else. I don't think it likes what this is. Yeah, that's what it is.
Yeah, because I have to go home to get ready for the master's thing.
What a master.
I don't know.
Just-
And maybe
How about you
something
search for
What?
confidence intervals for proportions? Alright,
I got you.
Who made these things?
you should see this.
Yeah.
Everybody see this,
Okay.
Yeah.
okay?
Is that have it? These back, Michael?
No.
Oh, yeah, sure,
Here, I'll find.
You click it.
You ready?
Please have that yard.
You,
Mom.
Please use the share of that yard.
for proportions.
Okay,
Don't.
Hey, guys,
yes, sir.
let's make better decisions.
Ah, ah.
Alright,
Don't do it.
so, have you followed the directions on the sheet and set your values?
Yes.
Population proportion to 0.5, confidence level to 80%, sample size to 100.
Don't even know.
Oh, let me scroll.
They got 7 on
Or you should make this, you should pass.
Okay. So, follow the directions. Guys, you got eyeballs. Click sample to select an SRS and display the resulting confidence interval. What is the point estimate? What is the margin of error? You might have to zoom in some. There you go.
Oh, you want us to?
Try sample one.
Sample one.
Jaden, I may need that.
Jaden tries to kill me.
Huh?
I may need that iPad. What's that face for? Hello?
Yep,
Hey,
sample.
we got 8 minutes. Let's try to get some stuff down.
I did.
If you need to,
I will
look on
copy
with
off the
Peter.
front.
Oh.
Yeah.
Hit us. What's the green line?
What do you think it is?
That's probably the median.
That's the,
Or like the, so.
Let me ask you
It's
this.
like
What's P? What's your population proportion? 0.5?
yes.
So
Oh.
it gives you your point estimate and your margin error.
60, I think.
Wait, so how do
And then
I
your margin
see,
error would be
what's
So-
my point estimate?
So this is your first one.
Yeah.
Okay, what's the green is your true
Point
proportion.
estimate, plus or minus the what?
So
Oh,
CR is
okay.
confidence interval.
Under what?
So your first confidence
Like, I
interval.
mean, like everything. You can
What
do
was your
everything
point
on the
estimate?
Like we just, like this, drive by.
What was your point
So,
estimate?
So
That's your margin of error.
Yeah.
Plus or
No,
minus
what
that.
one is your point?
This is your point
estimate.
estimate. So what's your
Or
point
is it,
estimate?
because like you're adding or something.
Alright.
Okay, so do it again, but do it for 10.
Must be said.
And then
No,
what's the margin of
because that's
error?
your population proportion. Like this.
I got 3 on the same
What
one.
does this green line represent?
Does that mean population proportion?
Oh, sorry, my fault. And what does the green line represent? You tell me. What's that at?
What's ours?
Mhm.
It's not very high rate.
I mean,
I got 4 on the same thing.
So then, I go to 3, 4, 5.
Yeah, I got that.
Oh, you did, okay, you did.
I meant like 7.
Do you want me to
Oh,
write
yeah.
sample?
That's sketchy.
Wait, hold a second.
It said take a 12.
No, 10 samples, not a sample size of 10. Remember, we want a sample size of 10 samples. 1, 2, 3, 4, 5,
Oh my god.
6. There you go.
Wow.
10 samples. Be careful, guys, on the difference between sample size and number of samples.
Oh,
Mr.
that's
Kennedy.
something.
I can click this till it goes to 5,000.
Mr. Kenny,
Yeah.
5,000.
how did these applets truly like randomize it?
Uh,
Because I said they're not random because now we can't truly randomize.
I mean, it's just as random as a random number generator.
Yeah, it
So
captures
not
the true
even
meaning.
true.
What if I go 1 past?
So, I mean, they have a different
Or they're random enough.
seed.
They're
Well, they have different seeding values.
Yeah,
So what if you have two
Just
that have
pretend
the
that
same
says
seed
10,
value?
so they all
Like
hit
by
it.
some
So.
I'm
extraordinary
sure that'll
chance.
happen at some point, but very
Yes.
unlikely.
So,
Reset,
let's go which
do
kind
it
of
again, but use.
Alright, quick question. Has everybody done their 10?
Yeah.
Yes.
Okay, what was the lowest capture rate of the parameter?
I got 0.832.
I got
No,
0.
so for when you did 10, right?
I got 0.43.
No, got it, hold on, no.
What are you talking
On your 10 intervals,
Uh-huh.
when we did it here, when Ms. Kowalski just did it, she captured the true proportion how many times?
Oh.
All
I
10
heard
times,
10 times.
okay? What was the lowest capture rate we had?
We had,
I have 25.
we had.
So you hit half the time? So you hit 5 and you missed
We
5?
hit 0.7.
And you hit 7 out of 10?
Yes.
I had 1.9.
So you hit 9 out of 10? Why are we getting different capture rates? Sampling variability, right? So we need to recognize sampling variability here. Alright? What does it have us doing after that? Collecting a total of,
100. Oh, 100.
so you have a total of what, 5,000 samples? Oh no, we go up to 100? Okay, so you go to 100, you there? Alright, so can you see what rate our intervals captured at?
0.88.
0.88. Alright, let's go out to 5,000.
It took me forever.
I know, it takes a while, doesn't it? I need y'all to notice
Like,
the
yeah.
percent that hits. What is this getting closer and closer to?
It's just lower.
100.
It's getting lower and lower.
100.
There's something that you're missing. What's it getting closer and closer to?
50.
true proportion?
That's 0.811, 0.812, 0.812.
Yeah, the true proportion. Oh yeah.
The confidence
Oh,
level.
sorry.
Say it again.
The confidence level.
What was our confidence level again?
Sorry.
Oh, wait,
Yes.
point
What was our confidence level?
0.6. Wait.
What was our confidence level? 80%. Thank you. Oh my gosh.
My bad.
And guys, what is this approaching? 80%.
Huh.
Why is it not there yet?
Because you have to get
There's
a
variability.
Like
You have to
which
get-
car?
Because we're missing what key idea?
Law of large numbers.
Law of large numbers.
I got
When do we hit 80% in the long run? So please understand,
I got one.
is it 80 out of every 100 intervals that'll capture?
I got one.
No.
No.
It's 80% in the long run. So what's that confidence level there mean? Oh, you already hit past 5,000.
it to me, you know?
Trying to get to 80, I've done that before. So make sure you have a note of your percent hit, right? And so if we take many samples, can you go back to the slides really quickly? Okay, so, next. So if we take many samples and calculate a confidence interval for each, about what percent of them will capture the true proportion?
80.
So in this case, right, 80%, but, so 80%, because that is the what?
Confidence.
Confidence,
Wait,
say it again?
level?
Level. We call that the confidence level of them will capture the true proportion
You can go past.
of,
You can't go
in
past.
general context, okay?
I know, I'm trying to.
Alright. So, please understand, does that mean, again, that 80 out of 100 will always capture?
No.
No, it means 80% in the long run, right? So I had to say probability. Can you go to the next one? Yes, please.
Oh.
Alright, so what's going to happen to the intervals when we change the confidence level? Okay? Without clicking reset. Please notice that it says without clicking reset. And I'm assuming some people didn't read, so I'm going to just show it really quickly here.
Thank you.
Reading, I know, it's rough. Alright, so I need y'all to look. Pay attention to these intervals over here. As that confidence level goes from 80% to 90% to 95%, what happened to those intervals? They're getting wider. Because to be more confident,
You know,
You're gonna have to be more.
we need a larger interval, so we need a larger what?
Variability.
Margin of
Right.
error.
margin of error.
We need a larger margin of error, right? We need more spread there. We need a larger interval, so we need a larger margin of error. Notice the calculator recorded everything. What's this percent hit really close to now? Really close to 95%, right? So we have to wrap up there. We'll pick up there tomorrow. First half of class tomorrow. We have a what? Test on sampling distribution. By the way, some people turn in their prayer models. If you want that back to help you study. We actually have several. Serena. Y'all weren't here last week. When I passed them back, Peter. I think this was Peter as well. These are all the old ones that you submitted like you were supposed to, unlike some people.
Jaden.
What?
I don't know whose this is. Peter, is this you?
Not mine.
What?
That's mine.
That is mine.
That was mine.
Peter,
What?
Why do you have so many?
Sprigg, and Nate. I did not get a chance to look at y'all's.
I thought I gave you mine. Oh, you mean the new one?
Yes. I didn't get a chance to look at those over the weekend, but use those to help you study. Turn back in tomorrow.
So am I.
You
No, no,
go for it. I was just gonna say, have a good flight. Have fun. Tell Miss
Hey, who's
Wilson
taking
bye and good luck.
Where
She
you
will
going,
be getting job interview tomorrow in New Jersey.
You're gonna be in New Jersey?
Will you let me back? I was waiting.
She'll be
You're
back
not gonna be
Wednesday.
back.
You're not
Oh, you're gonna be back?
Gas.
She'll be
the
back
best
on
thing ever.
Wednesday.
It's the bullshit.
I'll literally be back
It's the word.
Wednesday.
She flies out